So that's pretty cool, right? And I don't know who needs to hear this, but somebody does. Somebody in this room does. Make sure, like, your graph doesn't have to be perfect, but it does have to show that your points do correspond to what you have here, right? Don't just like draw a figure eight and hope for the best, okay? It has to be carefully labeled and plotted. Mine's not perfect. Yours doesn't have to be perfect, but, you know, make it show that you really plotted these points on here. Okay, so let's talk about this a little bit. Is this a function? Yeah, does it pass the vertical line test? It doesn't look like it passes the vertical line test. So is it a function or not? Well, look at x of t and y of t. X of t is a function. It's sine of 2t, right? If I graph sine of 2t, that just looks like that, right? It's a function. It does pass the vertical line test. And cosine of t just looks like that. It's a function. It does pass the vertical line test. X of t and y of t are functions. They pass the vertical line test. What you get as a result doesn't pass the vertical line test because the vertical line test doesn't really apply. The vertical line test should connect the independent variable to the dependent variable, okay? But the y here does not depend on x. The y depends on t, and the x depends on t. So if you were going to have a vertical line test, it would have to connect the t-axis. Where's the t-axis? Here's the x-axis, here's the y-axis. Where's the t-axis? Well, t is time, so it's floating out somewhere else in a different dimension of time. Now, is there in some sense a vertical line that we can draw between time and these points? Well, that depends on how much you're willing to expand your mind. I like to think that there is a way that makes sense, but essentially it would mean that I never have the same time going to two different values of x or y. So in other words, at the same time, the point can't be at two different places. So if we think of time going past, the point is really following a trajectory. It goes like this, right? So the idea of a function here is that that point can never be at 2 points, two different places at the same time. It can, of course, come back to the same place at different times. In fact, it does that, and on this domain, it does it here and here. So we sometimes have same place at different times, but you cannot have be in different places at the same time. That is the sense in which this figure is being described by two functions, even though it doesn't look like it passes the vertical line test in the classical sense. So this is called a Lissajous figure, what we just drew with the sine and cosine as x and y. And yes, it is also awesome. All right, so that's this and a little bit of discussion about it. I want to say something more about that. Oh yeah, so here's the next thing. Your calculator can just do this. Yeah, and Desmos can do it too. So here's how to do it for TI if we want to just make that. So some of these things we've already done. We already changed to parametric mode. In order to do the table, we did that. So we're already in parametric mode. You know, we can look at that if we want. We're in parametric mode. And then when we go to the y equals, well, we already put in the functions. All right, so we already did that. Now, under the window, if we look at the window now, we have to set Tmin and Tmax. That is here. All right, so we're setting it 0 to 2 pi. That 0 to 2 pi is this 0 to 2 pi. So that is the domain of the parametric variable, something that will come back to us. The domain of the parametric variable, there's a pi in this calculator, right? Yeah, 2 pi. We can just do that, and it's going to change it to 6.28. All right, is 0 to 2 pi. All right, what else do they set here? I thought it said something about t-step in here. Tmin, Tmax. Here. Yeah, it doesn't say. So that's something we're going to have to consider. So the t-step, the t-step is like resolution. How big a jumps did I take in these points? So in fact, the t-step is here from 0 to 0.3, 0.6, 0.9. So I jumped 3 points each time. if I set t-step at 0.1, I will, fill in those 3 missing points. All right, what else are we setting for window here? Is we're setting, we want -2 to 2 for our t-min and t-max, or our x-min and x-max, so -2 to 2. Let's see, the scale is 1 is fine, and then -2 to 2. All right. Now we just graph it. Graph, there it is. Oh, isn't that lovely? It looks just like this graph. Yeah. It's a parametric graph. All right. Now, it says, what if I change it to 6pi? Oh, it says let's change the line type to /0. So do you remember when we did that for motion graphs? We went over here and we went over, arrowing over to where the line is flashing, and then change that to the ball, right? The little ball. That's what I mean by that thing. All right, and look, we're going to set up the Tmax to 6pi. So if I go to the window, we're going to set the Tmax to be 6pi, 6 times pi. All right, what do you think is going to happen? How's it going to be different? So here we are tracing the graph, and you're going to see why I put the ball. Because it goes around again. Here's it's going a second time. And then it goes around a third time. So this shape is just going to retrace and retrace. So I could have the variable t, the time variable, go from 0 to infinity, and this thing would just go around and around and around. All right, but this is describing something that is moving back and forth like this, which, by the way, is exactly what bees do in order to communicate the distance to a honey source. Look that up. Dance of bees. Look that up on the YouTube. This is an exact replica of the way the bee dance communicates information. All right, so what happened when we went to 6pi? It traced the figure 3 times. So guess what? If we set it up to 12pi, it would trace 6 times. So basically it takes 2pi of time, 2pi units of time, to go all around this graph once. So if I have a larger unit of time, I'm just going to keep going around, around, around. Right. Some figures do that and repeat, some don't. All right, so that is a little bit about how your calculator graphs these things and where time is and how it's still a function and all that.